what we're going to talk about is we're going to talk about something known as the determinant. Okay? And so up here on the board, I need you to go ahead and write down what the definition of a determinant is. A determinant is a numerical value of a square array of numbers. It's a numerical value of a square array of numbers. Now, you can find determinants by hand. You can also find them through use of graphing calculator, through the use of GeoGebra, and we will, in fact, use GeoGebra eventually to find the determinant. And so this section actually then ties in something known as Cramer's rule, which is a way to solve a system of equations. If you remember last chapter, when we had our last test, we solved systems of 3 equations, x, y, and z, using algebra techniques. You can also use something known as Cramer's rule, which uses the determinant. And we're going to talk about that as well. So if you notice in the asterisks, I say that you can only find a determinant if the matrix is square. So if the matrix is not square to start with, that means that you can't find the determinant and you're done. Okay, it's it. And we symbolize the determinant by, if you notice those vertical lines, they look like absolute value signs. Okay, it's not absolute value signs. Okay, that actually symbolizes the determinant when we refer to a matrix. And so the difference here, remember when we were doing a normal matrix, if we were going to write it, we would use brackets. If, instead of brackets, if it looks like this, that means you find the determinant. Okay, so now how do we find the determinant? So here we go. The determinant of a 2 by 2 matrix, and it's different for when we get to the 3 by 3. Okay, so 2 by 2 is the smallest square matrix that you can find the determinant of. And so if you notice, all you're going to do is you're going to take A times D, which is the first diagonal. So A times D minus B times C. A times D minus B times C. So how does that work? Well, what we're going to go ahead and do, okay, is we're going to look at that matrix right there. Negative 3, 1, negative 1, negative 3. Negative 3, 1, negative 1, negative 3. So using the formula up above, what are you going to multiply? Negative 3 times negative 3. So what I'm going to do is I'm going to go ahead and multiply along this diagonal. And then what I'm going to do is subtract this diagonal. And so what does that look like? That looks like that. Negative 3 times negative 3 minus negative 1 times 1.
Does it matter what?
It matters the order.
But if it's B times C, then why does it show C times B?
It's the same thing.
Okay.
Okay? You could view it as DA minus CB. It's basically just the numbers along that diagonal. And so here, negative 3 times negative 3 we know is 9, minus negative 1, which in fact is 10. So, ready to go? Let's try one, see how we do.
So 10 is the answer?
10 is the answer. So 10 is your determinant. That is your final answer.
So you don't put it in those lines, right?
Nope, you don't put it in the lines. This is your final answer. The determinant is just a number. And there's a lot of things we can do. So here you go. Here is your chance. Find the determinant of that. Find the determinant. Probably have to turn your expression back on. You got the first one. see what you get. Go ahead and type your answer into your expression.
56.
And let's see what you come up with. And the answer is 11. So let's see how you get 11. So how you get 11 is we multiply along the first diagonal. So I multiply along this diagonal. So 3 times negative 1, which is negative 3. Then I multiply along this diagonal, which is negative 14. Now remember, it's minus negative 14. And so when you do that, your two negatives make a positive, and your answer is 11. Okay? All right, let's give you another chance. Here you go. We'll see if you get this one right. I threw a 0 in to see if I could trick some of you a little bit. Wow, close, close. Negative 8 and positive 8. So let's go through and see how that works. So if I multiply along the first diagonal, 8 times 0, I get 0. Now remember, I'm always going to subtract. And then here I have negative 4 times negative 2. Negative 4 times negative 2 is positive 8. So if you take 0 minus 8, you get negative 8 as your answer. Okay, so now we're going to look at the determinant of a 3 by 3 matrix. Now this is not quite as easy and fast. But if you pay attention, I'm going to show you a way that works real slick. Okay. So yeah, so you'll want to go ahead and make sure you write that down. A, B, C, D, E, F, G, H, I. 3 by 3. So now when I'm finding the determinant of a 3 by 3 matrix, the first thing you're going to do is you're going to take these first two columns, A, D, G, and B, E, H, and you're going to write those again, okay? And so what I mean when I say you're going to write those again, that's what it's going to look like. So just go ahead and write those same things again. You're going to duplicate whatever those columns are. So far, so good? Then what our next step is going to be to do, after I've duplicated those columns, is I'm going to multiply along some of the diagonals. So I'm going to start with this first diagonal right here. And I'm going to multiply up that diagonal. So if you have maybe a second color or something, you might want to do that. That might help kind of distinguish between the two. So I'm going to multiply along that first diagonal, G, E, C. And then what I'm going to do is multiply along the, oh, just a second. I'm going to multiply along the next diagonal. Oh, just a second. Just a second. We'll try and get that all figured out. I've got kind of one of those. Anyway, the other one you're going to multiply along. I'm supposed to have it. There we go. Oh my goodness, for some reason we're having some technical difficulties here. There we go. And then I'm going to multiply along. I have to get to that exact. Oh my goodness. You're going to multiply. Anyway, you're going to go ahead and multiply along all of the, there we go, along all of the diagonals. I'm sorry. There we go. There we go. Here we go. So you're going to multiply along all those diagonals. We finally got it to work. Maybe next time I shouldn't do the animation. Okay. Now, all of the pink diagonals are going to have negative signs. All of the blue diagonals are going to have positive signs. Okay, so let's go through that again. All of the pink diagonals are going to have minus signs. So you're just going to make whatever number that is the opposite. And all of the blue ones are going to have positive signs. So I'll let you go ahead and get that down. And then we're going to go ahead and look at an example in class. What? No. Nope. The pink here is all the negatives. The blue here is the positives. All right, so when everybody has that down, we'll go ahead and okay, so find the determinant. 2, 6, negative 1, negative 1, negative 3, 0, 5, 4, 7. Now I need to find the determinant here, so what's the very first thing I'm going to do? Rewrite the 2. Okay, so I'm going to rewrite the 2. Now this is what I do when I do this. I actually will start, I'm going to go this way. Okay, and so I'm going to go ahead and go up. And so when I go up, I'm going to get 5 times negative 3 times negative 1, which is what? 15. But since I'm got that 1, I'm going to make it the opposite. So it's actually going to be a negative 15. Now I'm going to go along this line. Yeah, there we go. And so I've got 4 times 0 times 2, which is 0. You're going to like the ones with 0. Okay, because the ones with 0, anytime you have a 0 in one of your diagonals, your answer is going to be 0. And then last but not least, I'm going to go ahead and multiply up this one. And what do you get? Negative 42. But remember, we're going to make it the opposite, which is positive 42. So if I add all those together, my answer is what for the top for the pink? 27. Now what I'm going to do is do the same thing now, except for I'm going to do the down diagonals. So the down diagonals, I'm going to start by going down on the first diagonal. And what do you get? Negative 42. Now remember, if I go down here, these ones stay the same as what they are. I don't adjust the sign any. Go down on the next diagonal, what do you get? 0. Go down the next diagonal, what do I get? What do I get? 4. What do I do with all those? Add them, and you get negative 38. So now what I do is I combine the two numbers. And I combine the blue and the pink. And when I combine those two, I get negative 11. And that is your determinant for this matrix. There's another way called the expansion by minors that is used to find the determinant. I think this way is a little quicker. And so that's the way we're going to use. Yes?
Okay, I thought you subtracted the pink.
I thought you what?
You said you subtracted pink.
I did. I changed all of the signs, so I made them all the opposites. So that was pretty much the subtraction.
What about the 0? How is that opposite?
0 is just 0. It's neither positive nor negative.
So you just changed them to positive?
Yep, I just changed their signs.
So are we going to do like a 4x4?
No. The only way that we're going to look at a 4x4 is if we would use GeoGebra. Okay, so now we're going to try one right here. Negative 3, 1, 2, negative 1, negative 3, negative 5, and negative 3, 1, 4. So what's the very first thing we do?
Copy it.
Yep, copy it, and we add our 2 columns. We add our 2 columns. So now what I want you to go ahead and do is I want you to go ahead and multiply up. I'll get you started on the very first one. So when I multiply up, what do I get on that first one?
18.
18, but remember, since that's a pink one, I'm going to make it a negative. And then you're going to do the same thing with the other two. Do your down arrows, combine them, and then when you get done, I want you to go ahead and enter it in on your expression.
So if you get a negative number, you put a positive.
Yep.
Negative.
You put the opposite one for the pinks. Now, did you get that figured out?
Yeah.
Good.
8 times 3 is 9 times 2 is 18. You have to keep timesing.
Which one? To get these numbers.
Okay, what we're going to do is put those up here. Okay. So then now, that was at 18, right? I made it negative because I went up. This one is going to be 1. It's negative 5. It's negative 3. It's 1. I'm going to make it negative since I went up. So whatever your answer is on these up ones, you're always going to do the opposite. So that one's going to be 4 times negative 1 times 1. Yep. And so they will add all those together. What do you do?
For the diagonals
You
going
do-
that way.
You don't add,
You'll do the bottoms. Let's just take care of get the top all right.
The diagonals going to the line, like starting here goes.
Yep, so negative 29 on the bottom. Now do the bottom ones. Now these ones are whatever the sign is that it was. So this one will be 3, negative 3, negative 3, positive 4. 36. Negative this one's 1, negative 5, and then you're going to do negative 1. So that address is
Look, they do.
combine those in one.
Three places.
So about 10, and you should be good to go. Okay, so let's see.
I got it.
No, I know. I was gonna let you enter it in.
Thanks, you're
I saw that you picked it up, so I was gonna go ahead and, let's see how we did. 20, nice job. You guys did great for the first one you tried on your own. That's excellent. So anyway, what you should have gotten on the top wasn't that one negative 29?
Yep.
Okay, so what ended up happening is you should have gotten negative 29 for the number on your top. On the bottom, you should have gotten 49. And so what happens is when you go ahead and add those two together, you get your answer of 20.
I got 1 on the top and 19 on the.
Okay, on the top, what you should have done when you multiplied this one, you should have gotten a negative 15. This diagonal here, you should have gotten a positive 4, which is negative 29. On your other diagonals going down here, you should have gotten 36, 15, and this one should be negative 2. And if you add those, you should have gotten 49. Now this is what you're going to be doing. This is all you're going to be doing today. The 2 by 2 and the 3 by 3. So what I need you to do, turn in your book to page 195.
Maybe this will do this, but when like you times those.
You add them. So on page 195, 26 through 37. Now we're going to look.
When I times those, it's negative 15. So when you take the negative, and then 50.
No, you have one on top. You're right.
What comes that?
But because we looked at that one again. I bet you just did something that was pretty odd.
Oh, yeah, that's right, yeah.
Okay, so real quick on page 195, where we are going, if you look at page 195, problems 39 through 46, that's where we're going. We're going to be able to solve those using matrices, using the determinant. Okay? And so I think those will be pretty easy. But what we're going to do is we're going to do this lesson over 2 days. And so the first part of the lesson is the determinants that we looked at today, so 26 through 37.